Welcome, welcome, welcome. All these heads pop up. How's everybody doing? Good, good. That was more people that answered, they expected I'd answered at 5 o'clock at the end of the day. So thank you very much for coming. My name is Adam Tuliper. I'm a technical evangelist with Microsoft working out of Southern California. I do a lot on the gaming side. I came from an enterprise background, and about 2 years ago, by accident, somebody at Hackathon mentioned something about Unity. And who knows about the dependency injection software, Unity? Right? And that's what I thought they were talking about. And I found out there's this whole game engine out there, and then that changed my career. So things happen in a kind of crazy way here. Don't forget to submit an evaluation. That's important to all of us, especially myself. We're going to be doing an overview of Unity. How many people are using Unity currently? A few folks. A third of the folks. All right, cool. We're going to be doing an overview. This is not going to be an intro to Unity session, although for the folks that haven't touched Unity, I'll cover just a couple of basic points in there so you're not totally lost looking at the interface and what we're doing. Tooling, where Microsoft fits in on the tooling story with Unity. And Universal Windows apps and the Universal Windows platform, talk about how we can build for that from Unity, some cross-device strategies, and where we're going, a little bit of a roadmap. So Unity and Visual Studio, my two favorite software products. Unity 5 is the recent version where they made some really cool announcements outside of feature support. They changed the licensing model on there. So if you get the free version or the pro version, they have the same basic feature set, about 99.999 of the same feature set. Pro gives you some additional cloud-based services, analytics, build, et cetera. Some of my favorite features I'll just talk about real quick here. Animation. If you have any sort of character in a T-pose, for example, let's say you just have a zombie that you bought from the asset store, which I'll talk about, or a designer created for you. You can take any animation, maybe somebody shooting an arrow or somebody doing a zombie walk, or I've seen one literally in a zombie game, I saw a zombie doing Gangnam Style dance. You can take those animations and apply them to any other character in a T-pose, so they're retargetable animations. The graphics engine was revamped in Unity 5, some amazing changes there to give essentially AAA quality lighting in your games. Optimizing, they've got a profiler built into Unity, as well as a frame debugger now as well. The audio system in Unity was also revamped in 5, and now they have an audio mixer. And 2D and 3D physics, they use two very well-known engines out there. And there are other products that use them as well, Box 2D and NVIDIA PhysX 3.3. That allows you to have hundreds of physics objects in your scenes, things bouncing around, colliding with each other. So very, very high performance now in Unity 5, things you couldn't do in the prior 4 versions. And from a scripting standpoint, it supports C#, and that's all I care about. The first image here is from a demo that you can see on Unity's site called Blacksmith. AAA quality demo they put out there. That character was using their animation system. The second time, their global illumination system, GI, that's included now in Unity 5. The third screenshot there is from the profiler. You want to look at memory analysis, draw calls, things like that. You can all do that inside of Unity. And lastly, their 2D tools, which we'll look at a little bit later on as well. Is Unity right for you? And there's one reason I show this slide. Unity has a 45% market share. The next closest competitor, 17%. And I don't want this to be a sales slide. I want it to be, from a developer standpoint, when I develop something, I want to know there's support out there for it, that there's a large community using that particular product. Millions of developers using Unity, and almost any question that you ask, you'll find they have a very Stack Overflow type format on their forums, and where people upvote, downvote, et cetera. And you'll find that almost any question you can go in and search on the net, you'll find that somebody has already asked before. And if not, there's a great community to help you out. All right, let's get right into a demo. And let's not be in presenter mode. Let's go and duplicate my screen. Do jumping jacks when you can see it. All right, yes. I didn't think anybody was going to move. Thank you. All right, so let's dive right in to show you what we're going to create and then how we can kind of piece it together before we do other things like bring it to the platform. So this is a fun game idea I just thought of fairly recently called Metal Warfare. I don't have the voice for that. So this is Metal Warfare. You're a tank. You're the driver of a tank. And you can do fun things like shoot stuff, come around and run into stuff, because that's what really happens in real life. Got some music. Oh, no. You get the idea. There's a timer counting down. You have 2 minutes, or it's doom, and a little ammo counter. It's a fairly decent-looking game. although from a standpoint, it's actually fairly simple. And it might look like it's a little complex, so we're going to kind of deconstruct this a little bit and see how we can actually build this up. So to do that, let's start with another instance of Unity I have open here. And I'll just show you kind of the steps I did to get here in just a new file, new project, my Unity demo. Unity supports 2D and 3D. It is a 3D engine, so even your 2D games are really a 3D environment. It's just fixing you to 2-axis while you're developing, but you can pop in and out of that. So it's very easy to make a 2.5D game, for example, where you mix 3D and 2D in the same game. Not my demo, my demo. Create the project, but before we do that, there's also this box here. And when I first started Unity development, I wanted to check everything off because I didn't know what they did. And don't do that. don't make that same mistake. Think of them as NuGet packages, in a sense. It's prepackaged functionality you can bring in your game. Some get installed by Unity by default right there, and you can bring them in from anywhere. If you download stuff from the asset store, which I'll show you shortly, those come down as Unity packages. I have a folder where I keep all of my favorite Unity packages in. They're just essentially compressed files with lots of functionality. It could be audio, scripts, images, 3D models, all packaged up in these nice little bundles. So just for this one, just to show you how we started building it out, checked off environment. And the environment package brings in some things like trees. Unity 5 now uses a speed tree system. Awesome tree system, also used in movies. And brings in some images that I can use to kind of texture my terrain out a little bit. And that's all I did. But just to save time, I will cancel that out and just show you the next step out of there. Now, the interface, again, this is an intro to Unity, but I do want to kind of talk about the interface for some of the folks that are new to Unity here. This is your virtual environment here. This is your level. This is your scene view. This is where you're going to do your design inside of Unity. Think of when you're working on a form, like an example designer or something. Everything here, this is what's in your scene. And over here are the properties of what's in your scene. Now, everything, 99.999% of everything, stems from a game object. Just like think about system.object in .NET, right? I'm going to say that again for the third time today. 999% of things in .NET inherit from system.object. Think of a game object as a root object for almost everything else. It has a basic name. It has a tag, just like in Visual Studio or when you're doing Windows Form or XAML development when you assign a tag to something. It's just a text string that you can use to describe something, or you can find something by a tag. So a name, a tag, and a transform, where it is in space. You can move things around, rotate them, scale them, and that equates to these buttons on the toolbar as well. Now, everything else after that are components. Everything comes to life by components. If I look at a light is nothing more than a game object. It's got these properties, and it's got this light component on top of there. If I look at a camera, it's also a game object. It has a camera component. That's what turns it into a camera. When you add a script, it gets added as a component to a game object. If I look at a cube, for example, a cube is a game object. It's got a mesh filter, which is responsible for reading the vertices out of the model and passing that over to this thing called a mesh renderer, which makes it visible or invisible. You ever see the games where you have this invisible border at the end of your level, and you're like, I wonder how the developers did that? It's an invisible border. That's exactly what happens. All right, so let's look at some of the built-in functionality. Unity is not a 3D modeling system, asterisk, because they do have some tools built in. You can do some 3D modeling, and there's third-party tools like ProBuilder, for example, where you can actually do modeling inside of Unity. But I'll show you one of the built-in systems here, since I use it to build out the game, and that's the terrain system. I'm going to create a new terrain, and it comes out as this plane here. I want to texture that. I want to add an image onto that terrain. And that's what this paintbrush here is for. So I highlight my terrain. I get all of its components. It's a game object with some other components here. And I click on the paintbrush, and I can add a texture. In other words, I can take an image and plaster it all over there. So I'm going to add a texture here and select it. And if I search for ground or grass, there's a couple basic ones in this pack. First one gets applied, goes all over the entire surface. So you can see it's repeatable. How do you change that in a real-world environment? You know, when we saw this game right here, if you get close, sometimes some things look repeatable, but by mixing it up, by overlaying different textures on top of it. You can see here I've got some sand. There's a base texture. There's a little bit of a green texture. So by randomizing your terrain, things look a little bit different. Now, we need to sculpt this out, and it's another thing that we can do with our terrain tools here. The first one, raise or lower terrain. And I think this is like my favorite tool in Unity because you can do cool things like this. Start drawing stuff out. If you want to paint something like a plateau or mesa, to be specific, that one's a little high. Paint those up. You can actually use another tool in here to come in and erode them down a little bit more. So some of these are very jagged, not realistic looking, so you can erode those down a little bit more. And as you can raise, so can you shrink. If I want a little pathway for my troops to run through there, or a little canyon valley, make it a little randomized, not so straight. And just like that, we have a basic terrain. Of course, I would want to take other images and plaster it on there. But that's how you sculpt out your terrain. Take a bunch of images, plaster it on top of there, and paint it. And you have your paintbrush, and you can add one or more textures on there to paint. The next thing I did was brought in a couple trees. And again, Unity uses the speed tree system. So if we search for some trees, our environment pack that we brought in gives us a couple trees. Add those, and I could paint a big area, but let's be sparing. I'm from California. There's not much water left in California, so I'm going to be a little sparing with these trees here. You guys are like, all right, what happens if you crank that up and click an area? That's what happens. Or my favorite button of all time, mass place trees. Let's get 1,000 trees. There we go. So just like that, we can do grass, we can paint rocks on there, we can do all these other different textures. Those are built-in tools in Unity. Well, you saw in the game we actually had more than just that involved. And so that kind of brought me over to the asset store. I was a software architect for many years before joining Microsoft, and I can draw a mean stick figure, and that's about it. So if I want to create a game that looks somewhat cool, then I go ahead and grab stuff from the asset store. I know a couple designers, but most of what I use, I grab from the asset store. And I think that's what makes Unity one of the most powerful marketplaces. I work with a lot of game devs, a lot of indie devs, development shops, game shops, and near everybody I talk to uses something from the asset store. They might not use a zombie from the asset store. They might use scripts that extend Unity's interface. But we can grab, you want 3D models for your game, you want free 3D models or pay 3D models. Here's a whole bunch of free ones listed there. Zombie, female character pack. Download them, and you can use them inside of your game without any kind of royalties. The free ones are free. The pay ones you download and use them in your game. Done. You want audio for your game. Perfect. Free audio, pay audio, very, very high quality assets on there. And so in making out Metal Warfare, the tank game I showed you at the beginning, I grabbed a couple packs off the asset store. I got some audio. I grabbed a tank pack. I actually grabbed the helicopter pack. I grabbed a Middle East pack on there. And that brought me over to this. So I took that terrain and just kind of changed that a little bit. I brought in some rocks. You can kind of see here, took a couple different images, painted that up. But now the magic happens in the rest of it. So we have a basic terrain here, some concrete on the side of there. Next was taking some of these prefabs, prefabricated objects that you can just take and drop into your scene. You can make your own prefabs in Unity. Literally, you take something from here, and you drag it down to there, and it becomes a prefab. And then you can reuse it across your scenes. These prefabs are things that this designer said, hey, I want to give you reusable bits of information. So these are the prefabs. And if we want another rock, for example, take a rock there. Of course, stacking those up side by side would look a little bit goofy. So it's all about randomizing. Placing in your environment, randomizing your things, scaling them up, scaling them down a little bit. Randomize, randomize, randomize. So we got some rocks there. We could take, we've got a hangar. A couple little guard towers. Bring those into focus, look at those. Those look all right. And it's all about just taking kind of the minute details in there, right? We can drag big things around, but what about little things like fence, for example? Frame that. So you get the idea. Take objects, snap them together, make these environments. So that's about what it looks like there. The next step on there was taking one of the other packs that I got and prefabs vehicles. And to be clear, I did write a little bit of code around there. I didn't quite like the way that it operated, this physics tank controller, so I wanted to change some of the functionality. It was a first person. I wanted to make a little AI into it. So I did make a little bit of code changes on there. But it did work out of the box. So you can see how this level here actually looks pretty similar to the one that I showed you in the beginning here. That's it. We've got our tank there. We've got a helicopter, also in that asset pack. I got a script that actually will piece apart your meshes. It reads all your vertices and just destroys it when you collide with it or hit it or do whatever you want to do. So using all the power from the asset store, I kind of created a game here. And I hired a designer to do a little bit of work, which I'll talk about in just a tiny, tiny bit here. So we've got this game. Let's talk about some of the tooling that we have to make things a little bit easier for the game developer, for somebody using Unity here. We purchased a company called Syntax Tree within the last year, and they had a product called Unity VS. And it was to use Unity with Visual Studio. And it was about a $100 plugin that you pulled into Unity. I know a lot of folks that loved it, they used it, but it also cost $100. So we bought them, and we turned around and we made this product free. And this allows you to use Visual Studio to edit and debug code. The default is monodevelop. And who uses Visual Studio, right? Probably everybody raised their hand, most people. And so this allows you to use Visual Studio to not only edit, but also to debug your code in Unity, which we'll look at shortly. This makes the two integrate together pretty seamlessly. This gives you shader syntax highlighting, IntelliSense like you'd expect kind of in an IDE, code templates, one of my favorite features of that, and full debugging support. With Unity, you can use any text editor that you want, but you just can't debug your code. Out of the box, it works with monodevelop. This allows you to now use Visual Studio to debug your code. So what happens is a plugin gets installed in Visual Studio. You install a package into your game. And the two of them uses the existing interfaces that monodevelop uses to talk back and forth. There's a soft debugger that Mono uses. And it allows you to talk back and forth between Visual Studio and Unity. So it uses the same underlying mechanism that monodevelop uses as well. Anybody hear about this? The Partnership for Tools. We've announced that we're working with Unity, and the Visual Studio Community Edition is going to be an option during install for Unity and some other tools as well, where during setup, click, and you have Visual Studio Community Edition as your code editor on there. So it's going to work very seamlessly there as well. You can use monodevelop as well if you still want to use monodevelop, but I'm a Visual Studio guy. All right, let's look at what that looks like. I was excited when this partnership happened, because I think this is one of the coolest tools. So to get it, you can look for Visual Studio Tools for Unity, VSTU folks call it. You can also go to unityvs.com, select the version that you want. Easy as that, downloads and installs in your system. The installer installs a plugin in Visual Studio for you and installs an asset package, like I was talking about earlier, a Unity package that Unity can see. So let's look at what that looks like. Let's take this basic one that we did before. And under Assets Import Package, we can always bring in those little checkboxes that I showed you in the beginning, that new project dialog. We can always bring those in later at any time. We can either use these. We can double-click on one on our system. We don't have to use these. I just want to show you that Visual Studio Tools for Unity installs here. And it gets listed as Visual Studio 2015 Tools. You click on that, and it tells you, hey, this is what's inside of that Unity package file. And there's just these two libraries. So we import that. That's it. Done. A new menu appears up here, Generate Project Files. You typically don't have to click that. This runs just automatic. But I will show you another change that happens here. Inside of Unity, if you want to change your text editor or see what your code editor is, Edit Preferences, External Tools. The default is monodevelop. As soon as you install this tooling, it switches to this file opener, unityvs.openfile. Close that out. Let's go ahead and create a C# script here. We will make, let's make an evil cube. So I'm going to create a little class called Cube Controller. It's very important to make sure that your file name matches your class name, or otherwise things won't work. Double click on it. Visual Studio opens up. All right, there's my new empty class. Unity gives you a new class with two methods built into it, two very common methods. There's probably about 7 that you use on occasion, maybe even less. Gives you start and update. Start gets called when this object is starting up. Update gets called every frame, but let's add something more into here. One of the things that I love and I use all the time with Visual Studio Tools for Unity is trying to remember what these methods are in Unity. If I know I want to detect collision between two objects, I know there's an onCollision enter, there's an onTrigger enter if that object's a trigger, there's onTrigger enter 2D if it's a 2D object, onCollision enter 2D if it's a 2D object, and the method signatures change each time. There's different parameters that get passed in them. So trying to remember the API call sometimes is a little difficult. So Control-Shift-M brings you up these helpers that are installed by VSTU. And this gives you all the common Unity methods that you would use. And it will generate those method stubs for you. So for example, we'll have two objects that collide here. So if I can see on collision enter, not 2D, on collision enter, this guy right there, go ahead and insert that. And here we have it right there. Void on collision enter. Let me reset my size here. For some reason, my control seems to be stuck here. There we go. So let's say if this particular game object, so the code is assigned to a game object, if who we've just collided with, collision.gameObject. We can get IntelliSense here for our Unity properties, or Unity objects. So if we've collided with the player, let's go ahead and just destroy ourselves. Destroy this game object in 2 seconds. And we'll set a breakpoint there, so we're very used to this process. Now notice, we don't have to worry about this. We don't have to worry about the debug, the release. This has changed, right? We're used to seeing something like debug, and we can launch an emulator and all sorts of stuff there. Right now, we have attached to Unity or attached to Unity in play. So if we want to debug this, we would just click that. I'll show you that in 1 second. We need to do a little bit more background work here. I'm saying if I collide with the player, destroy. Well, we haven't assigned this code to anything yet. So let's just do a real basic example here. And I'll create a game object. I'll create a cube. We'll put that at 1, 1, 1. We'll duplicate that cube and move this guy up so we know he's going to fall on him. In order to fall, we need to give an object a rigid body component. If you're using Unity, you're very familiar with that. You want to give an object mass and gravity, you simply give it a rigid body. And we'll see it fall now. The code's not on yet. There we go. It falls. Let's go ahead and take that code, give that to our cubes, and let's make the top cube the player. It's just a tag. It's just a string we're assigning to it. All right, let's go ahead and debug our code. Attach to Unity. All right, we come over here, and let's go ahead and play. Boom. As soon as that object collided, we get thrown into Visual Studio. Unity is actually hung up right now because we're in the middle of a debug call right now. So if we want to continue this, we can just either F5 or continue. Let me move this window down so you see. And all the same debugging exists here. If you want to see all of your watches, if you want to get all of your helpers here, it all works as you would expect to work inside of Visual Studio. So this is extremely useful. We'll say continue. After 2 seconds, there we go. Destroys itself. The other thing that the Visual Studio Tools for Unity gives you is shader syntax highlighting. So just a little bit easier on the eyes if you're writing any custom shaders, just to get that syntax highlighting inside of your shaders there. So another nice little feature there. When you're done, you just click stop. You don't have to detach from a process, or it's not going to kill Unity. You just click stop, and now you're all done. All right. So that was a cool tooling with Unity. The next thing that we have are diagnostics. And you can use the Visual Studio Graphics Debugger for diagnostics. It gives you some really low-level information. Typically, you want to use this when things aren't displaying right and you need to get to the bottom of what's going on. This has full Unity support. And this will give you the ability to capture one or multiple frames, low-level debugging on there. And we'll look at a little example of this. But very important point, this requires Visual Studio 2013 CTP 5 or above, where it won't work right with Unity. So full Unity support, but make sure you have the right version to be able to support that. And let's get right to a demo. I have a build that I created of the game. We're going to look at the end. It's cart before the horse a little bit. I have a build I created of the game because I want to show you the graphics tools here. And so what I want to do for this is show you the various options first. We can, under the Debug Graphics menu in Visual Studio, debug and install that package. So any applications that you have installed locally on your system, you can debug those. If I bring up that list here, you'll see all the different store app packages installed on the system. And you have a couple different options if you want to do script only, native only, if you only want to look at the GPU or mixed, manage and native. And then you could start debugging on that. But I actually have a build here of Metal Warfare, so we're going to look at that. And let's go debug, graphics, start diagnostics. Game gets launched. Say yes to that. Let's try to get it right when I shoot. I'm going to shoot and then use my, thank goodness for touch screens. I can just touch my screen at the same time here. There we go, caught that. Now, a word of warning here. I was doing some debugging, and I thought I only captured a couple frames, and I looked at the information behind the scenes, and I had 7 gigs of data captured. So you get a lot of data for that low-level diagnostics, so just be careful about how long you're going to be doing captures for. You can capture, again, as I said, 1 or multiple frames. I actually have a project loaded up here that I did with a good capture on it that I want to show you here. Same thing that we're right at the point of impact on that barracks there, on that hangar, I should say. And you can get all the list of all of your draw calls here. So one of the things when you're dealing with performance on games, everything gets drawn out many times a second. And the more draw calls that you have per frame issued, the slower that your game is likely going to run. And per each draw call, you can look at some really low-level information, what the shader was, source code of the shader, et cetera. But you can also come in here and see, let's scroll this down a little bit here. If I see that something looks a little bit weird on a particular object in my scene, maybe I have a pink object coming up, which can happen if you have shader issues, or if you just want to see how your scene is being composed, click on a particular pixel. And for any pixel that you select in your scene, so let's select something here from my HUD element, and you see kind of its history here. For that single pixel on your screen, gives you its value, tells you the initial color here, what happened on this first one here. So that pixel got written out as kind of this generic sky there with a blue color. And then at some point in time after that, draw call 40342, that's not in a direct number order. There was not 40,000 draw calls here. Now you can see the difference between the two of them. I have no GUI, no HUD element there. And the very next one drew that image on top of there. And you can see its actual value there. And down below, you can see the shader and what happened on that particular element here. Just that particular element was drawn out. And you can get even more information than that. So just kind of a quasi-high-level view of the information you get with that graphics debugger on there. Very, very easy to launch and very, very powerful. And it captures a lot of information. More information than you could ever want. Or maybe want. You might be that hardcore. All right, let's go back to. Does anybody use a graphics debugger yet? Couple folks? All right. Are you using 7 gigs of data? Tooling recap. Every Unity edition can use Visual Studio. So if you're on Visual Studio, if you're on Unity 4, on Unity 5, and free or professional, you can use Visual Studio Tools for Unity and Visual Studio Community Edition or above. So if you have a retail version of Visual Studio, it works fine. If you're using Visual Studio Express, you'll need to upgrade that to Visual Studio Community Edition. Control-Shift-M in the Visual Studio Tools for Unity, I think, is one of the best things because I always forget the method signatures. That gives you all the generated lists, and you can just click one, and it gives you the generates that code for you. And the graphics debugger for low-level diagnostics, low-level information. Unity actually has as version 5, they have a frame-level debugger, so to say, built in Unity. The Visual Studio one here gives you so much cool information. All right, next let's talk about the Universal Windows Platform, or UWP, that you guys have probably heard about 187 times today. How do you go from your game to all of these different devices? This idea of this universal platform running on everything in the world, how do you take a game and deliver that there? You've got phone, phablets, small tablets, large tablets, 2-in-1s, classic laptops, desktop all-in-ones, HoloLens, Xbox, Surface Hub, and more to come, I'm sure, that aren't listed on there. There's probably going to be, who knows, crazy stuff down the road. Movie screen displays, probably. The process is actually pretty simple to take your game over to there. And you start with Unity, of course, and Unity will, in turn, export your compiled project as a Visual Studio solution. You open up that Visual Studio solution, and then you in turn do something with that solution. The build process is pretty easy, so let's go ahead and look at that. Inside of Unity, so I've got my complete scene here. This is the one that ran just like this. I just like hearing that cannon. That's why I keep starting it. So I go to Build Settings. Who knows the build shortcut in Visual Studio? It's the same one, which makes it really, really handy for those that like shortcuts. Control-Shift-B. And inside of here, we need a scene. So there's a game that we're working on. We have, I think, 40 different scene files in our project. Some test ones to test out controllers. Do I want all those going in my final project? No. In this one, I only want this particular one scene. You can either drag and drop into there. You can put multiple ones in there. I'm just going to add my current scene in there. And we're going to build for Windows Store. Now, previously, if you look at a version of Unity that you all have access to currently, you'll see there's Windows Store in there. And we can target Windows 8, Windows 8.1. We can target Phone 8.1, and we can target Universal 8.1. Of course, you can see kind of the path going like this to this one store and this one platform. And you'll see here, pretend for a moment that the A is a W, and this actually says UWP, Universal Windows Platform. You have two different project types you can select here, XAML, Direct3D. I like C# and XAML. I'm going to choose XAML here. And this other one is also pretty cool. The Unity C# projects, when you do your build from here to generate your Visual Studio solution, it will take all of your source code that you have inside of Unity and package those up and create separate projects for those and add them as references to your final game. So you can actually go in and debug your code. And one of the neat things that we've done working together with Unity is you can actually go in the Visual Studio, close Unity, go in the Visual Studio, say, oh, you know what? I don't like that line of code. I can make a change. Compile in Visual Studio. It actually calls back off to Unity to recompile it. With certain exceptions, you can't make a huge amount of serializable changes to your class. You can make certain code changes, and it will just come back and work without having to go through that whole build process again. So I'm going to build this, and I'm going to create a new folder, call it Demo UWP. There we go, it's building my assets, my scene, post-processing. They do a lot of work behind the scenes to take all this stuff up and package it up so it just works. You're not going to get access to all the low-level Unity engine, for example. It's not like you're going to see the source code for every single thing going on there. They package it up nicely into this solution. Let's run that, Metal Warfare. There are a couple things to be aware of. While that's loading, let me come back here into Unity. For the player settings, you have a couple different ways of specifying the details that get pushed down to your package.appx manifest file. So that's the settings that has your capabilities, tells what your image assets are, your splash screen, your icon, your wide icon, your medium icon, your small icon, all that kind of stuff is specified in your package.appx manifest file. Now, you can go into the Visual Studio side and set those if you want, or you can do it on the Unity side, and that's what all these are for. Right here, there's your splash screen image. If you want to set the various icons, you can do it here. And all that does is it pushes it down to the Visual Studio project the first time you build it. Repeated builds will not overwrite it. So just a word of caution that if you come in and change it and build again, unless you delete that folder, it won't overwrite it. So we've done our build. Here we have it. There's a couple options here. ARM and x86. Now notice this project opened up by default with ARM. I'm not running on an ARM system here. I'm running on an x86 base system, so I'm going to change that over to x86. When would I choose ARM? If I'm going to deploy out to a phone, then I would be choosing ARM. Debug, master, and release. Now think about in Visual Studio, typically for .NET projects, how many build settings do we have? We have configurations, I should say, two types, right? We have debug and release. Release is production, ship it, and debug is debug, not optimize. Well, now we have 3 for our Unity projects, and each serve a good purpose. Debug is, of course, not optimized, supports the Unity's profiler and not optimized. The next level up is release. Release is in the middle, not at the top on this one. And release is optimized, but it also supports Unity's profiler. And master is a fully optimized, doesn't support the profiler. That's the build that gets shipped out. That's the one that's going to go to your customers. That's the one that you're going to ideally upload to the store. Fully optimized, no profiler support. Master, when you're dealing with universal Windows apps, that's going to, as its last pass, do a .NET native compilation on there. So the process, as of right now, on the bits I have, can take a little bit. So I'm going to show you, we're going to do a release build today. Again, remember that's that middle build. Let's go ahead and run that. While that's compiling, you see over here this data folder. That is what Unity will overwrite every time. So repeat builds from Unity and pushing it down to Visual Studio just overwrites their own data folder. So if I add my own custom source code there, maybe I want to do my own in-app purchases and write my own native code there, I can do it that way. There we go. So I've got my game. It's running actually pretty good. I just want to hear it again. Cool. Scales. The default apps for your universal Windows apps, they will open up in a windowed environment like this, which to me I think just looks better, especially from a game standpoint here. Just keep in mind that users can do this. They can come in here and resize the applications. They can scale this. So keep this in mind, and we're going to touch upon this shortly. All right, one more time. OK, cool. So that's deploying to a local machine. Now, if you are in the mood to run things slowly, you can run your game inside of an emulator. I don't recommend doing that. I always recommend testing on as much physical hardware as you can. So if you want to deploy out to a phone, for example, you switch the device, plug a phone in, change the ARM, and run it, and it deploys it out to your Windows Phone. You can run it in a simulator. Remember, the simulator is not an emulator. It's a simulator. So if you want to check out different pixel density displays, you want to fake a 26-inch display and see how your game looks, you can do that inside of the simulator. You can test out some of this inside of Unity, and we'll look at that kind of the next section when we talk about their UI. But really, it's really, really, really important to test out on different display sizes, use a simulator, scale things out. We were working on a game once, and there's a software that actually takes screenshots running at all these different resolutions. And what I thought looked good on my system, works on my machine, man, it looked awful on about 90% of the other resolutions. So definitely test that out. All righty. So thinking about other devices here, talking about phone and going to desktop, we have to consider cross-device strategies. There's a couple different ways to do this. But we are in an era now where you want to take one build, or you can take one build, and run it on a variety of devices. From a development standpoint, sometimes it's a lot easier to do that than have to do separate build here, separate build there, separate build there, separate build there. The first thing you want to look at is designing for different screens. And there's tooling that's built inside of Unity that can help you handle this. So multiple resolutions, different aspect ratios, different device capabilities you're going to run across. Screen resizing. So when we ran the game just a minute ago, you saw that I took that window and dragged it. Expect that users are not going to run it at necessarily fixed aspect ratio. They're going to run it at full screen. They might window it. That's up to the user to control. So we can use a couple things built in Unity for this right now, and we're working with them on iterating on going forward on some cool techniques here. So Unity UI, which I'll show you a demo of in a second, is one way of doing this. Formerly called UGUI. If you've ever heard of UGUI, it's now called Unity UI, user interface. Another technique you can use are called asset bundles. Asset bundles require a little bit more work to set up, but if you have, for example, a high-definition tank that you want on the Xbox and a low-definition tank that you want on mobile, for example, you basically assign them to different asset bundles, a high-def one and a low-def one. And then at runtime, when your app loads, you pull them down from the internet, or you stream them from some source, and the infrastructure is built into Unity to load those packages up. So that's one technique of doing that. Another one is using the UI system to target multi-screen layouts. And so let's look at what I did here for Metal Warfare. So there's kind of the basic HUD heads-up display that was designed there. Let's come into a level here that doesn't have it. I basically just duplicated that one and took it back out. I talked to a designer, and I said, hey, working on a tank game, what is your awesome artistic vision? Because I can do stick figures. You do better than me. So what can you come up with? And he said, well, how's this? I was like, that looks great. So much better than I can do. So he gave me the assets for that, all these separate ones, and I brought them into my project folder here. If I want to take this guy and drag it up in my scene, you notice it doesn't work quite like that. There's this 2D mode inside of Unity. And underneath our game object menu, UI, we can create all these different elements that we've been able to do if you want to make the comparison to Visual Studio, right? Panel, buttons, text, images, slider, scroll bar. So all of these different components you would think of, these different UI elements. You can do a lot of these inside of Unity, and you can create your own custom one. This system is an open source system. You can find the code for it out on the net. So let's go ahead and do an image. Now, clearly, that's not what I want, because if I look at that, that image is plastered. Great, I have a heads-up display. Ship it. It's done, but that's not what I want at all. On that particular image itself, I'm going to take that top left image and bring it over here and drop that guy on there. And I need to preserve my aspect ratio, because that's not what I want there. Preserve my aspect ratio. So the thing I can do, if you notice this box surrounding my screen here, this is representative of the current screen I'm on. Notice as I change my window size, that changes. So think of that as the box that's going to define the resolution, the size, the aspect ratio of whatever system you're running on, whether it's a phone or like this system. And so this is a good way to test it out. You can actually scale it here and see how that changes. So if I bring this guy up in the top left, this was my top left HUD element, and I go to my game tab here to see what that would look like based on its first frame. As I start scaling, notice that's not what I want. This thing disappears. And I can see what's happening here if I go to the side. It's actually just getting pushed off. That's because its anchor point is in the center of the screen. So everything it's doing is relative to that point. It's basically saying, oh, I'm fixed over there. You want me to move over? I'm going to stay fixed to that. And just like we can in Visual Studio, we can anchor different UI elements around. We can do the same thing inside of Unity. And that's what this guy's for over here. Rather than a transform, our 2D objects have a rect transform object. And on our rect transform, this little drop down, we get docking options that kind of reminded me of what I would do with buttons inside of Visual Studio. So if I want to dock to the top left, this will move it to the top left and anchor it for me. So I can hold down Shift and Alt, move it to the top left. And I can see that my anchor point is now up there. So if I look at my game and I scale this out, you can see that image stays the same size. It's not getting smaller, but it's also not getting pushed off the side of the screen anymore. And so easy way to handle that is I take my anchor points, which is actually 4 points. They look bundled up there into one. And I can just bring them around to the edge of my object, like that. And now I'm saying you are anchoring these 4 corners, essentially pinning it there. And that's going to be relative to how I'm scaling the screen out. So notice, as I get smaller, it scales smaller. I can do the same thing with text boxes on there. Sometimes I want default anchoring positions. So that top middle one that we did here, let's take a new image here, game object UI image, and give it that top middle, set the aspect ratio. I'm going to dock this to top middle. Well, it just so happens that because it's in the top middle there, and its anchor is right there, I kind of like that. That works all right. Now, of course, it's not changing size, so I would probably want to bring this out here to the edges, and that to the edge. Again, you can do this with all the UI elements. You get the idea. This is just 2 elements here. Fully scales out, and so easiest way to deal with multi-device resolution. Pin your objects, test it out. Unity gives you some helpers right in here. And there's some pretty cool stuff available in the Unity Asset Store as well that will actually set a whole bunch of these for you and take screenshots for you at all different resolutions and show you a gallery. This is what it looks like across 50 devices. You can test in some basic aspect ratios here. So I can see what it looks like on a 16:9 or 4:3. And you can add your own on there. If you're working with a particular device and you want to add your own resolution on there or your own aspect ratio, you can do that as well. Very easy to set up. All right, next, sharing code. When you have platform-specific code that you want it to run this way on one platform and this way on a different platform, you can use preprocessor directives inside of Unity. And there's a whole bunch of them that are built in. This one would say, if I'm building for Unity, the name hasn't been changed yet here, so Unity UAP. Imagine for me the A is a W, that's UWP. So if we're building currently for UWP and I'm not running in Unity's editor, then go ahead and compile that bit of code into there. And we can take that a step further. You'll see that very common inside of Unity projects. Folks will target all different platforms. I want to do in-app purchases on iOS here using that. I want to do Android over here. I want to do Windows over here. So this is very common to see this type of code inside of Unity. Another thing you can do is you can write plugins. You could do this before. They changed the plugin model in Unity 5, and I'll show you that in 1 second here. But from a high-level standpoint here, you have 2 libraries. You have one that has your functionality built into it. That has your API that's going to be used when Unity builds your Visual Studio project. It loops that guy in. When you are running inside of Unity, Unity is an environment, it's a virtual environment that runs Mono. Mono, not .NET for Windows Store, different requirements, different API. And so you need to say that, hey, when you're compiling for Windows Store, I want you to use this library. And when you're running it inside of Unity's editor, you're going to use this stub library that has some fake function calls in there, or however you want it to act in Unity's editor. And that's a second library. So 2 libraries. And inside of Unity itself, you have settings that basically say, hey, when you compile, use this library. And when you're running in the editor, use this one. Let's look at what that actually looks like here. This is a real basic example. I have 2 projects I generated. One, I did a file new project. And on that new project, I specified that this was a Windows Universal class library. So it's going to understand that code and that namespace and compile a particular way. Again, that does not work inside of Unity's editor. Unity runs on a particular version of Mono inside their own little virtual environment. Secondly, I have a stub library. And this particular library here, if we look at, this is a .NET Framework 3.5. So that has the same API compatibility with what's running inside of Unity's editor. This is my stub library. This is what I have, the code that's just going to fake something out for me. Well, how do I fake it out? Real easy way of doing this is you share your code between these projects. If you've ever seen this, if I say add an existing item, and I point to a C# file, if you're not familiar with this, add is link. You add a source code project, a file to your project, but it doesn't copy it into your project. It just links to it somewhere else. If there's any web developers in here, you'll see this extensively throughout the MVC source code, for example. That's actually the first place I ever saw it. So you add it as a link. And the cool thing that happens is when I compile here for my Windows Universal library, this is true. How do I know it's true? Well, easy enough. I just look at my properties. And I can see, oh, here's my conditional compilation symbols, NetFX Core and Windows UAP. So I know that's true. So when I compile this, this is going to work. And I'm asking the new API, hey, is this particular contract present? Universal Window apps operate on this idea of contracts. Hey, is this contract present on the system? And I'm asking for that. Is this a phone? Do you support this phone contract? Well, this other stub library running inside of Unity's editor has no idea what that is. So if I look at that code, and you can see the icon is a little bit different here. It's just a linked C# file. This is no longer true. This project doesn't know anything about it. And so when I compile, it's going to comment that out. So I take those 2 libraries, I drag them, I bring them over into Unity. And inside of Unity here, I go to Plugins. And in the new system, you can put them in a bunch of different locations. I just like to have a plugins folder because I'm old school. And I highlight the library. I just drag and drop in here, platformtools.dll. And I can specify, hey, this particular version is going to be used only when you compile for Windows Store apps. Or this is the stub library, and you're going to use this when somebody comes in the editor and clicks play. So you specify which platform you want it to be used for, and Unity will smartly pull that in at the time when it needs it. Any source code changes you make behind the scene, Unity will compile for you automatically. So when you click on play right here, Unity has already grabbed your source code and compiled it. It's not a manual step. It just happens automatically. And so the same principle happens here. You check these off, and this just happens automatically. Pretty cool, right? Right. All right, next, just a high-level detail of where are we going? How, when, what? The stuff that you're seeing now is going to be targeted in Unity 5.2. 5.2 is not out yet. Unity's working hard at making that available in the coming months. Remember that Unity Pro licenses, so free and pro from a software feature set, are basically the same level as each other. Unity Pro, you get these additional cloud services, analytics, et cetera, but you also get access to beta versions when they become available. This one's not available yet. They're working hard to make this available in the coming months. That's going to target Windows 10 with our one store. That store is going to have various device families in there. You're going to be able to target everything. You're going to be able to target mobile, desktop, Xbox. You can target all with one package or multiple packages as the same app. So the options are going to be there for you as a developer to do it however you want to target, one or individual. What else runs Windows 10? HoloLens. No, I don't have a HoloLens here. This is cool because there is currently, this was announced on Unity's blog this morning, so this is public information now, announcing support for Microsoft HoloLens. There is going to be a Unity SDK that team is working very hard and very awesome on. It's going to integrate right with Unity. You're going to be able to do some really cool stuff from Unity deploying out to HoloLens. So stay tuned for information on that. Now, building Windows 10 games, remember that Universal Windows Platform and Universal Windows Apps, they allow a single package. They are a single package. You can target one or you can target multiple. It's up to you as a developer. The bits you're going to want to look for are coming in Unity 5.2. Write your game and ensure that you're doing testing using all those different resolutions. Go into Visual Studio, run it in a simulator, run it on different devices. I like to use Unity even before I get to there and just change my aspect ratios, set it all up inside of Unity, see what it looks like. It's a real quick way to test it out. Platform-specific code, you can use plugins. It's not a difficult process. We just saw it. You have two libraries. One's a stub, one's not, and they just share a file between them. And you can compile that and just call that from within your Unity C# files. Super easy. And please take advantage of the tooling we've put out there. Microsoft Visual Studio Community Edition, Visual Studio Tools for Unity really create a cool experience running inside of Unity. Thank you very much. Stay tuned 1 second for a slide for some resources. Tomorrow morning, I will be, well, tonight from I think 6 to 8, we'll be doing the Expert Zone, and I think tomorrow morning I'll be working over the Insiders area. So if you have any questions, Unity game development, relationship advice, anything you want, come over and visit me over there. And thank you very much, and enjoy the rest of your build.